Moving on to question number 5, we have a car accelerates uniformly. This automatically should tell you that we're going to be using a TZA equations for constant acceleration. So have these handy in your data booklet. One thing I'd highly recommend while sitting in the exam is to know exactly where everything is in the data booklet so you can reference it at any time. You don't necessarily have to memorize everything, but knowing where everything is will save you a lot of time. And especially in Physics HL paper 1, this paper is meant to test your speed. So keep a lookout for that. The car passes point X at time t1. So let's label this time t1 with a velocity of v1. Let's label that as well. And point Y at time t2 with a velocity of v2. And of course, we're going to draw v2 bigger than v1 because it's been accelerating. Now, we've been given 3 expressions for the magnitude of acceleration a, and we're asked which is correct. Now, we can do this in many ways, but let's just start by defining the quantities that we know. First of all, we have delta t, which is t2 minus t1, correct? Next, we can use our Suvite equations. So we're seeing a t squared here. So this reminds me of the equation s is equal to ut plus half at squared, right? So when we take this into account, let's now rearrange and try to solve for a over here. Or let's go step by step. S minus ut is equal to half at squared. A is equal to 2 times s minus ut by t squared. Correct? And of course, t in this case is actually delta t. So we can simply replace those values. But here you will see that this is very clearly incorrect. This may be correct in a very particular case, but for this generalized case where the body is starting with the initial velocity, this is incorrect. So we can say 1 is incorrect. I'll just take a second to show this generalized case where this is correct. So when u is equal to 0, i.e. a body is starting from rest, your equation simplifies to 2s by t squared, which is 2s by t2 minus t1 whole squared. Now this may be a trick by the examiners to try to see who is simply memorizing the formulas and not actually applying it. So be sure to always apply your formulas and double check what's happening rather than simply memorizing something you see in the textbook. Now from here, in a time crunch situation, I would advise you to immediately select the option C, because we know that option A, B, and D must all be incorrect. However, for the sake of convenience, I will go ahead and prove the rest of these. For number 2, we will use the formula v squared minus u squared is equal to 2as. Now, of course, we have v equal to v2, u equal to v1, and that lets us rearrange as this. A is equal to v2 squared minus v1 squared by 2s. And so obviously this one is correct. And finally, we have a question for number 3. This one requires a little bit more critical thinking, but let's say we plot this on a graph, a VT graph. So point 1, this is x, where it is t1 comma v1, right? And we have y, which is t2 comma v2. Now connecting these with a straight line, which they have to be a straight line because it's a constant acceleration, we know that the slope of the straight line m is equal to the acceleration of the body, which is equal to v2 minus v1 by t2 minus t1. And that's it. So option 3 is also correct. So we can easily pick option number C for our final answer. But again, I reiterate, if you are in an actual exam, I would highly suggest just skipping this entire process of verifying 2 and 3 and doing C until you have time at the end.